Today's question is, find the value of summation k equal to 1 to infinity 1 over k times square root of k plus 1 plus k plus 1 times square root of k. Let's see how to find the value of this. Observe only the denominator part, which we have k times square root of k plus 1 plus k plus 1 times square root of k. Here this k doesn't have a square root, but here k plus 1 has a square root. So if you want to write the k also in terms of a square root, how can we write? Suppose if we have a, we can write in terms of square root, that is square root of a times square root of a. Square root of a times square root of a, we can write this as square root of a times a. So this we can write as square root of a power 2. The square root and square gets cancelled, we left only a. Same like that, here we have a k. This k we can write it as in terms of square root, that is square root of k times square root of k. And here we have square root of k plus 1 plus, same like that, if you want to write this k plus 1 also in terms of a square root, how can we write? We write this as square root of k plus 1 times square root of k plus 1 times, here we have a square root of k. Now observe only this term, square root of k times square root of k plus 1. These two terms we can write it as square root of k times k plus 1. Here we have square root of k plus, here also if you write these two terms are in one place, that is square root of k times k plus 1. So what we left? We left square root of k plus 1. Just write that. Now observe here. Here we have a square root of k times k plus 1 and here we have a square root of k times k plus 1. These two terms are common. So we can take this as common. In the first term, if you take it square root of k times k plus 1 as common, then we left only square root of k. Plus, in the second term, if you take it common, square root of k times k plus 1. So you left only square root of k plus 1. So what we have summation k equal to 1 to infinity 1 over, so we simplify the denominator. After we simplified, we got this, which is square root of k times k plus 1. Then what we left? We left square root of k plus square root of k plus 1. Now multiply the numerator and denominator by the conjugate of square root of k plus square root of k plus 1, which is square root of k plus 1 minus square root of k. It is in the form of a plus b and this is in the form of a minus b. So a plus b times a minus b, the formula is a square minus b square. So if you substitute this formula here, then these two terms is going to be a square minus b square. Here square and square root gets cancelled, we left only k plus 1 for the first term, minus, here square and square root gets cancelled, we left only k. Here this is plus k and this is minus k, these two gets cancelled, we left only plus 1. Square root of k into k plus 1 times 1, which is only square root of k into k plus 1. The numerator is square root of k plus 1 minus square root of k. At the numerator we have two terms. For these two terms the denominator is same. So that's why we can split it into two terms. So we can write this as square root of k plus 1 over square root of k times k plus 1 minus square root of k over square root of k times k plus 1. Denominator square root of k times k plus 1. We can write this as square root of k times square root of k plus 1, isn't it? Square root of k times square root of k plus 1. Here also we can write this as square root of k times square root of k plus 1, because we can cancel here. Then what we left? Summation k equal to 1 to infinity 1 over root k minus 1 over square root of k plus 1. Actually this is a telescoping series. So let's try to write first few terms. Let's write up to n terms. If you substitute k as 1, the first term is going to be 1 over square root of 1, which is only 1, minus, so we are substituting k as 1. So here 1 over square root of 1 plus 1, which is 2, square root of 2. So 1 over square root of 2 plus, now substitute k as 2, 1 over square root of 2 minus 1 over square root of 2 plus 1, which is 3. So square root of 3. Now substitute k as 3. So it is going to be 1 over square root of 3 minus 1 over square root of 4. So it is up to so on. We can write n terms. That is 1 over square root of n minus 1 over square root of n plus 1. Now observe here, all the intermediate terms gets cancelled, so we left only the first and last term, which is 1 minus 1 over square root of n plus 1. But this is only up to n terms, but our given summation is up to infinity terms. So that's why here we need to take limit. Now we have to take n tends to infinity. This summation k equal to 1 to infinity 1 over square root of k minus 1 over square root of k plus 1, we convert like this. Now we have to find out limit n tends to infinity 1 minus 1 over square root of n plus 1. Limit n tends to infinity 1, which is going to be only 1, minus limit n tends to infinity 1 over square root of n plus 1. Here instead of n you have to substitute as infinity. So 1 over square root of infinity, the value is 0. So this value is 0. 1 minus 0 is nothing but 1. So therefore finally the summation k equal to 1 to infinity 1 over k times square root of k plus 1 plus k plus 1 times square root of k, the value is 1. That's it. If you like this video, please like, share and subscribe to my channel. Thank you for watching.